Good afternoon, everybody, and thank you very much for tuning in to this virtual science workshop on some of the science topics forming the backbone of the Daedalus EE-10 space mission candidate. As you know, this virtual conference replaces an original Splinter meeting that was foreseen on this very day at the EGU General Assembly, and we are delighted that so many of you chose to attend this alternative format. My name is Alex Hoffman, and I work as a mission scientist at the European Space Agency, and I'm supporting the Daedalus work. I have the pleasure today of introducing the larger framework and programmatic context in which Daedalus is set before handing you over to the exciting series of speakers that will take you through some of the science that Daedalus seeks to address. Next, please. So Daedalus sits neatly at the boundary between Earth and space science, and it has been proposed as a mission in ESA's Earth Observation Program Directorate. In EOP, we endeavor to develop Earth observation systems that address key scientific, but also societal challenges, and this with European as well as with global partners. We do so by developing a fleet of Earth-observing spacecraft and systems that target a full range of geophysical parameters and variables that describe the health and the state of our home planet. Next, please. We developed these within our Living Planet program and with a comprehensive approach to understand our planet in an Earth systems perspective. And we seek to describe the various processes that make up the Earth system and how these processes are interlinked. Within the Living Planet program, we follow three main programmatic lines. So we have Earthwatch, Copernicus, and the Earth Explorers as the main science and research focused arm, which I will briefly take you through next. Earthwatch facilitates the delivery of Earth observation data for use in operational services, and this includes our meteorological missions that are developed jointly with EUMETSAT. Copernicus is implemented with the European Commission in terms of the Sentinel satellites, and it aims to deliver robust, long-term operational data sets of a large range of parameters that keep track of the state of our planet. And finally, the Earth Explorer missions, which specifically target key scientific and research challenges, and this often in innovative ways. We currently have 8 Earth Explorers flown or flying or in implementation. And last summer, the 9th mission was selected during a user consultation meeting in Cambridge. And that was Forum, a mission looking at the far infrared outgoing radiation as a key missing part of the climate puzzle. And finally, Daedalus is one candidate amongst 3 for EE-10, which are all undergoing currently competitive phase 0 feasibility studies. So the Earth Explorers really are a science-driven program, and mission selection is proposed by an independent peer committee of experts, which is called the Advisory Committee for Earth Observation, or ACEO. And ESA flies on average one such new mission every 2 years. The first one was GOCE, which described Earth's gravity field and geoid to great detail, followed by SMOST for measuring soil moisture and ocean salinity, and CryoSat looking at ice in the cryosphere. You will all be very familiar with SWARM, obviously, mapping Earth's magnetic field. And recently we launched AEOLUS, which measures the global winds with a Doppler LiDAR system. Next up will be EarthCare, looking into aerosol cloud radiation interactions, and Biomass, seeking to quantify the biomass throughout our forests. And finally, we have FLEX, shedding light on vegetation fluorescence to understand vegetation health and photosynthesis. And the call for E10 was released in September 2017, and 3 mission candidates were down-selected for a year later to go into a competitive phase 0 mission definition and feasibility study. And amongst the candidates is, of course, Daedalus, which needs little further introduction, and it will be the topic of today's workshop. Next to Daedalus, we have Harmony, which consists in 2 passive antenna or 2 antenna satellites flying in close formation with Sentinel-1 to form a bistatic synthetic aperture radar system. Harmony seeks to measure small surface deformations in our oceans, land, and ice masses. And then finally, we have Hydroterra, which is another C-band synthetic aperture radar system, but on a geosynchronous orbit, looking at Africa and Europe in particular. Hydroterra intends to monitor processes and components within the diurnal water cycle, such as atmospheric humidity, soil moisture, intense rainfall, and associated impacts. So before handing you over to our great lineup of speakers, I would like to briefly take you through the selection process and our timeline and the teams that are involved. If I may draw your attention to the upper right sketch in this slide, you will see that we have two major groups that support this work. On the science side, we have the Mission Advisory Group, many of which have joined us today and have organized this meeting as well. And the MAG is supported through contracted science study and campaign teams. The science teams provide us with the detailed definition of the science needs of this mission and also assess its maturity and its performance on a scientific level. But very importantly, they also provide the requirements that are channeled into the technical concepts and feasibility studies. And here we have two competing parallel industry consortia to propose the system concepts. All of these groups will provide us with crucial inputs to write a mission requirements document and a report for assessment, which are the key input for mission evaluation at the end of phase 0. At the end of this year, we will have a mission definition review, followed by a meeting with our advisory committee for Earth observation, ACEO, which will then provide a recommendation for 2 candidates to be down selected into phase A. Phase A then is another competitive feasibility study of a year or a year and a half, culminating in a public user consultation meeting, followed by another ACEO recommendation to finally select the mission that will be implemented for a launch that is foreseen around the 2028 timeframe. And this is roughly what I wanted to share with you today. I would like to thank you very much for your attention and for tuning in. Thank again our organizers and our speakers, and I hope you will have an interesting and informative afternoon of talks, giving some aspects of the Daedalus science background. Thank you very much for your attention, and I shall stop sharing my screen at this point in time, or I can leave this on until Theodoros takes over.
Thank you, Alex, for a very nice introduction and the time frame given and the possibilities. So are there already now questions from the auditorium? So if not, I think we are on good track and we are all motivated in Daedalus to go a long way ahead.